Okay, hopefully you guys can hear me okay and see the screen. I'm going to go over the assignment for today so that you can see it clearly. I'm going to put key up here. Today is August 25th. So naming all the possible names for this angle. There's the 3-letter names. So I'm going to put the angle symbol and then I can go like A, C, D. C is the vertex, that's why it has to be the one in the middle. And then I can go backwards, so I can go angle D, C, A. Sorry, that D looks ugly. It doesn't have to be A though, we can also do the same thing with B, so it can be B, C, D. We can go in reverse again, so we can go D, C, B. We're still going to have C in the middle because C is the vertex still. Hopefully this focus is back in. Okay, and then because it's the only angle here, we can also just call it by its vertex name, which would be one letter, like angle C. So for example, my full name is Frank Wendell. If I'm in a room and I'm the only Frank there, they would just call me Frank. If there was more than one, you'd have to call me Frank Wendell, so you know which one you're talking about, Frank W, something like that. So over here, if we only have one angle on that vertex, we can call it by the short name. If it's something like this, we wouldn't be able to use that vertex name of it. We'd have to go with the longer name. Okay, second part says ray DB is bisecting the angle ADC. It says the angle ADB is 2x. So if you look, ADB, this one over here is 2x. It says angle ADC is 64. Watch out, ADC is both of these together is 64. But because right here it said that we had this ray is bisecting the angle, we know that these two angles have to be exactly the same. I'm going to put those little marks to show congruence. If this is 64 and this is split right down the center, that means that the left and the right side are 32 each. So that means I can go 2x equals 32. Now you can divide both sides. You get x is 16. One of the questions was asking what's x. We already found it, 16. The other one's asking for angle BDC. BDC is this side, 32. Make sure you're reading the directions on what's given and then what's it asking for. Next one, number 3, says two complementary angles measure 2x plus 10 and 3x minus 20. So because of this word complementary, I know these have to add up to make 90 degrees. So that's what I'm going to write for my equation. So 2x plus 10 plus 3x minus 20 equals 90. Because complementary, they add up to 90 degrees. Then you need to combine like terms. 2x and 3x is 5x. 10 and minus 20 is actually going to be negative 10. You're going to add 10 to both sides. And you're going to divide by 5. So now we know that x is worth 20. The question did not ask for x. So we need to actually substitute this back into the angles to find out what we get. So if you put 20 into this first part, you're going to go 2 times 20 plus 10. And that's going to be 40 plus 10. You're going to get 50 degrees for one angle. And then on the other one, you're going to substitute x is still going to be, okay, focused. X is still going to be 20, so it's going to be 3 times 20, and then minus 20. So this is going to be 60 minus 20, so that's going to be 40. And at the end of it, it makes sense because if they're complementary, they're supposed to add up to 90. 50 plus 40 does make 90. Okay, these statements, they're going according to what we've done already. So the right angles always make 90 degrees. Remember, acute is less than 90 degrees, and obtuse has to be greater than 90 but less than 180 because 180 is a straight angle. Okay, second part, supplementary angles. Supplementary add up to 180, complementary 90. So if you have two angles that add up to 180, supplementary. If it's two angles that add up to only 90, it's complementary. And then linear pair are both supplementary. I ran out of room here, so I'm just going to put sup with two P's. And they're also adjacent. So, like for example, down in here, supplementary angles could be like FBA and then ABC, because together they make the angle FBC, which is straight across, which would be 180 degrees. So number 5, angle EBF is congruent to this angle over here. So EBF is this large obtuse angle up here on the top left, so then that matches with ABC or CBA. And then it says name a linear pair. Oh, almost missed this one. Adjacent angles share a common vertex. Sorry about that. Okay, back to number 6. Name a linear pair. So linear pair are two angles that share the same vertex and they add up to 180 degrees. So I mentioned that one earlier. You can go FBA and this angle over here, which would be angle ABC. You could also go FBA and the angle on top of it, which would be FBE. There's other ones. Those are just two. Name two obtuse vertical angles. So obtuse, remember those are the big angles, the ones that are more than 90. Vertical angles are the ones that go across the vertex. So like these two angles right here, to get from this bottom right to this top left, you're going across the vertex. So these are vertical angles, and these are the big angles. So you can say angle FBE and angle for this bottom one ABC. You cannot use the single letter name because there's a lot of angles on this one vertex. Number 8, EBC is supplementary too. So if I'm looking at EBC, these two angles put together, EBC, it is supplementary to both the angle down here and the angle up here on top. I'm gonna go with this top one. So EBC is supplementary to EBF. Number 9, it's asking if they're perpendicular. That's what this symbol means. 90 degrees when they add up. So these two, when they meet. So BF and BA, BF goes out this way, BA goes down that way. There's no 90 degree here, there's no right angle here, and it actually looks like an acute angle on this side. Over here it looks like an obtuse angle. Either way, on this side's acute. BF, BA, that's not 90 degrees, that's not a right angle, so is it? No. Number 10, these are the vertical angle and linear pair relationships again. So 35 and Y are vertical angles. That one's easy, they have to be exactly the same. I don't have to add, subtract, multiply, or divide that. I don't have to make an equation, just recognize vertical angles have to be the same. And then 5x and y, these two angles right here are supplementary because they're linear pairs. And then if we know that this side is 35, just like that side, we could have done it over here. We're going to go 5x and the 35 together are supplementary, they add up to 180. You subtract 35 from both sides, 5x equals 145. And then after that, you divide both sides by 5 to get x by itself. Your x turns out to be 29. Question was asking for x. Put the answer. You're done with that problem. So over here on number 11, 82 is vertical angles with y going across the vertex right there. So that's the easy one. You don't have to do any work, just recognize it. And then once again, these two angles are supplementary. So x and 82 has to make 180. Subtract 82 from both sides. X equals 98. Right? So x is 98. And then if you know that this side is 98, vertical angles tells you that z is also going to be 98. Number 12. we don't have any of these angles that we actually have what the measurement is, but since these two use the same variable, here's where we're going to start. So 3x plus 15 has to equal x plus 31 because those are vertical angles, and vertical angles are always going to measure the same thing. Subtract 3x from both sides to move this x across. You're going to have 2x on the left. Subtract 15 to move it to the right. You have 16 on the right. Divide both sides by 2 to get the x by itself. And we already know that x is 8. Here's one of the answers. And then if you know this variable is 8, you can substitute it over here. So it'd be 8 and 31 makes this 39. And then you would subtract 180 minus 39, and you get 141 for y. And that's it. So I'm going to be in the classroom after you've tried the work, and you check the answer key. If this video still doesn't answer your questions, if it's still class time, I'm going to be there. And if it's after school, today is August 25th, 2020. I will be after school from 3 to 4 o'clock.